Just unwrap my visual aid. So I just thought I don't have very much stuff to say really. I just thought I'd talk a little bit about Raspberry Pi, where it came from, how I think it perhaps relates to some of this stuff, and certainly how it kind of our aspirations for getting back to a place where I think we used to be in the UK with computing, and where we maybe aren't anymore. So I have one here. I guess I could maybe pass it around most usefully. These things are becoming somewhat less rare now, but I still have this kind of get the shiver whenever one leaves my hands, because for the best part of a year these have been substantially rarer than used to. So I guess 5-minute history of Raspberry Pi. I used to work at the University in Cambridge. I used to be a director of studies, which is my college. The role of a director of studies, amongst other things, is to commission undergraduate teaching, but we also interview prospective undergraduates. We interview people who are 16, 17, who'd like to come to university and read computer science. And I guess I started doing this in 2004, because I went up to Cambridge in 1996. Same year as you, Richard? Yeah. So Richard and I went to Cambridge in '96, and when we went there, the competition to get onto the computer science course was extremely fierce, and we could rely on the vast majority of people who were admitted being able to program in an assembly language on a bunch of machines, probably 2 machines. It's quite common, people who could program on one of the 8-bit machines and one of the 16-bit machines. There did seem to be a sort of a Spectrum ST group of people, and there was the BBC Micro Amiga group of people, and I'm afraid to say it was BBC Micro Amiga person. And that was great, and we had vast numbers of people who they come in the door and they knew exactly what they were doing. The first thing that the course had to do was take those people, break them down, and demonstrate to them that they knew nothing, which they did using functional programming generally, and modular 3 as well. And that was a great situation to be in, because one of the problems at Cambridge is that the terms are very short. So an entire undergraduate program that takes you through from leaving school to notionally being able to do a PhD lasts has about 60-ish weeks of contact time. That's about right. You've got kind of two 8-week terms a year and a 4-week half term a year for 3 years. So it was really helpful to be able to get people in the door and have them know what they were doing. Now, by the time I was a director of studies, what I found was the number of people applying had pretty much halved. So we started off in the 90s with maybe a contention ratio of 6 to 1. So we had 6 applicants for every place. Down to maybe a contention ratio of 2 or 3 to 1. And the people who were coming in the door, rather than being assembly language programmers, had maybe done a little bit of web design. And that really sucks quite badly, actually, if you're trying to run a 3-year computer science course. And we looked around for reasons why this might have happened. One of the things that came to us was that we all used to have machines like this. And you didn't necessarily buy them to learn to program on. You maybe bought one to play games on, or you had one bought for you to do schoolwork on. But it just sat there in your room, and every time you turned it on, it went beep, and you could start typing BASIC. Lots of my friends knew how to write that 2-line computer program: 10 print I am skill, or 10 print something filthy, 20 go to 10, and then go to Dixon's and type that into all the machines, and then hit enter on all the machines and run out of the door. And even people who didn't go into programming, as adults. And this had the effect that people were just kind of beguiled into programming. I was beguiled into programming. In fact, the first programming I did, although I never owned a Spectrum, the first programming I did was on my cousin's 48K. And that just gave us a generation of people who program computers, and that went away. So games consoles at the bottom end, I guess, and PC at the high end. Games consoles aren't programmable by definition. And part of their business model is they're not programmable. PCs are programmable, but you have to want to program. There's a little tiny energy barrier, which is downloading some programming tools off the internet, and no one ever gets over that energy barrier. So those two things together in the 1990s kind of killed off the stuff that we see here. And I guess kind of 10 years after that happens, 10 years after you kill off kids having readily programmable computers, the universities feel it, 3 years after universities feel it, industry feels it. And we're now in a situation where I work for a company called Broadcom, my day job. There are no 20-something-year-olds. I'm 34, and I'm the young guy in the office. There really aren't that many people younger than me. Recruitment involves poaching experienced engineers, people our age, from other companies, not bringing graduates. So anyway, we're at university. We had this problem. We looked around and we came up with this hypothesis for what might have gone wrong. And so we sat down and tried to figure out if we could build a piece of hardware that was cheap enough that we could give it to kids. It was programmable enough that those kids could use it to get some of the experiences we have as children. And that was a long time ago. That was starting in 2004. We started to think seriously about it in about 2006. We founded the foundation 2008, and we've had prototypes for about a year. And these things have been shipping since last month. So it's been kind of a long ride. We get compared a lot to the BBC Micro. I think because of some of the involvement of some of our trustees. We have David Braben as one of our trustees, and obviously he's a long-time BBC Micro guy. We have Jack Lamb, who was also deeply involved in the original BBC Micro OS project. But I think really, technologically, we owe a little bit more to this strain of very cost-engineered development than we do to the kind of BBC Micro, which was the kind of bells and whistles thing. I don't know whether, maybe the Beagleboard is the BBC Micro, and we're the ZX Spectrum.
Well, your chip is pretty bells and whistles, but the rest of it is...
Yeah. What we've ended up with is just as some of the Sinclair products were really a Z80 and a Z80 and some RAM and the very minimum amount of extra stuff you need to turn those two things into a computer. So we really are an SoC, an ARM-based SoC, admittedly a fairly deluxe ARM-based SoC, and some RAM, and the very minimum amount of external componentry we need. So just where we're at now. We launched on the 29th of February at 7 a.m. in the UK. 6 a.m. Damn it. Pauline informed about my own project. We launched at 6 a.m. Yeah, it was 7 a.m. on the continent, wasn't it? So I understand that our distributors have shipped to everyone who ordered before 1 minute past, 5 minutes past. Almost. So we're kind of currently in the middle of this insanely steep ramp. We are very, very lucky to have had the assistance both of RS components and also of Element 14 Premier Final, both of whom have taken on not just the challenge of distributing these things, which is alarming enough on its own, but also the challenge of getting them built. And the consequence of working with these guys is, I believe we're on track to do a couple 100,000 probably total, a couple 100,000 this quarter. Obviously, some of you may have seen on our website, we've had some little bumps in the road along the way, and we didn't realise we needed to be CE marked. It's a bit careless. We got through that. We're very, very hopeful. We know where the rungs on the ladder are, right? The rungs on the ladder. Someone's going to correct me when I get these volumes wrong. Probably you. BBC Master 200,000 units.
Don't know, April.
Okay. BBC Micro about 1.5 to 2 million units. Spectrum 5.
Oh, it's totally.
Spectrum about 5 million units. Commodore 64 17 million units.
Well, that's a global thing.
Yes, absolutely. So we know where the rungs on the ladder are. We think we can get them. We've just got the bottom rung, so that's good. We think we can get the BBC Micro. We're coming for you. We've been absolutely amazed by the amount of enthusiasm for this. This was something that was targeted at children. We've been amazed and really gratified by the level of enthusiasm from adults, people who like to hack in their spare time, people who are nostalgic for what I think was personally a better and more interesting era of computing than the one we live in now. And also people in the developing world. That was one that we really haven't imagined and probably should have done. So yeah, we'd be interested to see where we go. It's a wild ride. I guess that's really all. Oh, I had my Spectrum anecdote. We obviously one of the interesting things about doing this is having the experience of quality control, having the experience of bringing up factories in building units with a very high level of reliability. And again, this is somewhere we've had an enormous amount of assistance from our distribution partners. I had a Spectrum story when I went into the office and I told a friend of mine about some of the challenges we've been having. He's about 50, so he was a student at the time that the very first Spectrums came out of the door, and he told me about his summer job. And apparently, his summer job was sitting on a floor in Greenock up in Scotland with an enormous pile of ZX Spectrum power supplies, transformers, finding out which ones worked, and discovering that exactly two in three power supplies worked. This was his first experience of doing some kind of process debugging. And discovered the reason 2 and 3 work is that these were manufactured in the factory in Ireland, and the windings for the transformers were hand wound. And the ladies who did this were provided with bobbins of wire for doing this. And the bobbin of wire was approximately long enough to make 3 transformers. Nobody had told these ladies that if you run out of, you get through halfway through a winding and you run out of wire, that you need to join the new wire onto the old wire rather than starting a new wire. So it's the sort of thing kind of we take heart from when we have had challenges in production. At least we haven't had that kind of challenge in finish. So yeah, I guess that's all I have to say. I would encourage people to come to our website, have a look at raspberrypi.org.
It's great.
It is great. Liz, my wife, is responsible for all the social media. Awesome. Yeah, absolutely. I'm just in a velvet glove. Just come and check us out, because I think we are trying to change things a little bit. We're trying to get back to this kind of world where people actually have some sort of idea what happens inside the shiny box and what we'd be. So thanks very much.
Eben, thank you very much. Thank you very much indeed. Please also give a round of applause to introduce Bill from RS, who is coming to. We're going to do a Q&A with both Eben and Ben. So please introduce Bill as well.
Hi, I'm Phil Marshall from RS Components. So I represent the vicious capitalist industry that's been holding back the whole project.
In fact, it's holding back equal to making it actually happen.
Well, yes, that's what we're doing our best. I have a similar background to Eben, although a lot further back, somewhat older. I first built a ZX80 as a postgraduate, and then 81, and then went on from there. Had a Spectrum for quite some time, particularly with micro drives. Unfortunately, I sold it, which I now regret, of course, but I do have all the bits behind as well. And I recently came across a Jupiter Ace, actually, in my loft, which I've got at the time, so that's got some rarity value. I'd just like to reiterate what Emma was saying about the importance of this project to education. I used to be a university lecturer and admissions tutor at Loughborough University, and I certainly noticed that the standard of knowledge was falling rapidly. I know that a lot of people have said, well, A-levels aren't what they were. Well, they're not what they were. To be honest, I think people are recognising that. Michael Gove the other day, when he suddenly said ICT qualifications are not very good, well, we knew that 15 years ago, basically, that things were going wrong. But of course, it was not particularly correct to say so. Now it is. Now, my perspective is from engineering rather than pure computer science. I'm electronics. The way I see Raspberry Pi working is actually helping to inspire people to play with hardware, not just doing the programming. So what I'm looking for is for the people such as yourselves to come up with all the add-on boards and things like that, which will allow it to be interfaced to robots and all sorts of other things. Now, notice I've seen some fantastic stuff here today with people programming the Spectrum, do all sorts of things they probably couldn't do before, and emulators and everything. Well, I think the time has come now to switch your energy to the Raspberry Pi. I don't mean port another emulator across to it. I mean, what we need is have the same impact as BBC Micro and Spectrum did when they first came out. Because in those days, nobody had a computer. So it was a tremendous novelty. So you get away with murder up to a point because nobody knew what a computer really was, and so their expectations weren't very high. Now people's expectations are very high, and kids will realise that actually their iPhone S is probably more powerful than the Pi when they really get down to it.
Not for graphics.
Not for graphics. But but nevertheless, the concept of the home computer is everywhere. It's not the same. It's not the same environment that you had with the BBC Micro. Schools are full of computers when they weren't then. So what we need now is proper teaching materials which can overcome the fact that people are very blasé about computers. That the kids can say, well, I've got one of these at home. What do I need to bother programming it for? So we will need a lot of extra stuff at a very high level. One of the advantages of this whole project is it's based on open source hardware and software. So most of the material is being produced effectively by volunteers for free, which is obviously, in the one sense, very powerful because it means an awful lot of really good stuff can be produced and distributed and doesn't cost anybody anything. It does have a downside in terms of quality control and getting things done when you need them to be done, which of course is a bit where manufacturers and people like us have trouble because we expect things to happen and then they don't. You say, well, I'm only doing this as a voluntary thing, I didn't realise I had to do it by a certain deadline. So, that's the downside, but I think that we can overcome that, and it is being overcome now. We have got people who are producing education materials, and we need a lot more. So, I think the time has come to move on. As much as I love the Spectrum and all its derivatives, we need some really good stuff working with Raspberry Pi now, and it's a tremendous platform to do that. Thank you. Questions?
Does anyone have any questions for Eben, Phil? Okay, so it's...
Yes, when am I going to get my Raspberry?
Do you know, I didn't think any of it would last that long. Well, the RS and Farnell are working in partnership. I know you wouldn't think so, but we are. We get equal numbers of stock when they come in, and we are working together to get the big batches manufactured. So it's not as if there's a big fight going on and lots of argument. We've shipped the first 700, I believe, now to the first batch, which only went out a few weeks ago. Yesterday or the day before, we started sending out the emails for the next 4,000, which should be coming in next week. And of course that immediately caused the website to fall over, and in spite of the fact that we have diverted everything from the main RS website to a special with roomfuls of blade servers able to take denial of service attacks and everything. In spite of that, it was still looking pretty flaky, but I think most people got through all right and got theirs ordered, and assuming the next batch come in, they will get them. I can't say precise details of what's happening after that. We are certainly getting back to the 25,000 and ramping up, but that's sort of being dealt with by another department, so I'm not totally au fait with all the figures just yet. But we aim to satisfy the full demand, and we want to get to a stage where we're beyond just saying one per customer, because obviously we want to be able to ship blocks of them to schools, which is after all the whole point of the exercise really.
Hi, how would you say they compare to Arduinos? What's the differences there? And over things.
Should I take this? Because I know something about they're better at some things and worse at others. So we have more good things about us. We have more memory, we have more processing power. We run a general purpose operating system, and we can drive a display. Those are the good things about us. Good things about Arduino: very, very low power, and much more interfacing out of the box, and much more robust interfacing out of the box. So we have a certain amount of digital GPIO. We have I2C and SPI coming out of the expansion connector, the 0.1. So we have a 0.1 inch pitch expansion connector. These are all at 3.3 volts. They're all unbuffered out of a fairly modern ASIC. So they are not especially fragile. They're certainly not as well buffered, say, as an output from an AVR like they use on the Apple. What we don't have is any analog in, and I think that's a big area where, for a lot of the projects that Arduino's used for, Arduino is superior. So we've actually, a chap called Simon Monk has put a really nice tutorial online in the last week in which he connects an Arduino Uno to a Raspberry Pi.
I'll be sticking a link to that on the website next week, actually.
Yeah, there'll be a link on the website next week, apparently. But it's really nice, actually, it just works. So the nice thing about the Uno is that it appears as it has a Cypress Bridge chip on it that makes it appear as a virtual serial port device. And so you can just connect them together and start talking. You just plug it into a USB port, a virtual serial device just appears, and then you start talking to it, and you can make the Arduino do stuff. So we see them kind of as a natural pair. I'm very much hoping that distributors will maybe sell bundles at some point. I know we've talked to both distributors about the possibility of offering bundled Arduino and Raspberry Pi together. And I think that would be it gives you the best of both platforms.
So you see them being.
Yeah, I think there's been a really unhelpful tendency to set us up as a competitor to a number of platforms that exist. I guess the obvious ones are Arduino, Beagleboard, and probably Cotton Candy. But I think those are three platforms that have very different targets and are good at very different things. So we absolutely see them as being complementary, not competing with each other.
Yes, it's like the Arduino is in fact a very much less powerful machine. You can't do anything like what you can do on like a Raspberry Pi on an Arduino. It's only a simple 8-bit microcontroller. It does have ASP converters and things like that, but it is chalk and cheese. That if you use something like an Arduino for interfacing to various bits of hardware, controlling fridges and all that kind of thing, where Raspberry Pi would be massive overkill. But you can envisage Raspberry Pi doing a lot of stuff which involves high-speed graphics and multimedia, internet, and all that kind of stuff. So they are compatible. I mean, I think it's horses for courses. There's no way there's a competition between them really in practice.
How did you come up with the name Raspberry Pi?
How did I come up with the name Raspberry Pi? It was designed by committee, like all good things. The Raspberry side is fruit named computer companies, of which there have been several, including Tangerine and Apricot, and apparently, and also Acorn, technically a fruit. So that's it, right? So fruit named computer companies, and the Pi was so we went through a lot of iterations trying to. There'd been kind of three obvious iterations of Raspberry Pi before the one that exists. The first one was actually based on Apple. The first one was very much like a Fignition, if you know that platform. It had an Atmel and a block of SRAM, and it was very spectrum, right? I mean, it generated its video signal by having the microcontroller sit there cranking addresses out through its GPIO ports, and falling into the RAM and then into the buffers and then into a ladder DAC and then out to the screen. It had RGB332 color graphics. And it was actually really cool. I built it myself. And the nice thing about it was you could build it using Veribord. It was all dip chips. So we had that, and then we had a version and that was going to run on Lua, and I kind of stopped before I did the Lua port for it. But then for a long time we worked on a version which used one of the earlier Broadcom graphics processors, and that had a port, didn't have an ARM on it, so you couldn't run Linux, but it had a port of Python to one of the custom RISC DSPs inside the chip. So Pi was Python. Was a misspelling of the Pi in Python. We thought there'd be some really nice graphic design possibilities with the Pi, which in the end we've ended up not using. We did a logo contest, and the logos that tried to use the Pi symbol actually ended up looking quite false. So we ended up not using it. But that's the story. I hated it for about the first year, but now I love it.
I appreciate all really busy doing it, but you mentioned a breakout board. Do you have plans for producing a similarly low-cost breakout board for the GPIO pins? Because obviously there's a lot of round of things you can plug into the USB, and they end up costing more than Pi itself.
I have seen, actually it came out on eBay, a small firm in Leicester sells a GPIO breakout board called Slice and Pie. I don't know why I'm advertising them, but it's about £3. It just plugs into the GPIO board and allows you, just spreads all the pins out, no buffering or anything on it, but allows the ZigBee RF chip to be plugged into it, to the socket, and brings out the RS-232 and things like that. So that's available now.
Right, and no buffering on that.
There's no extra buffering on there.
Well, that's what I meant. It's more with sort of the safety chips in it.
Well, there's another one of these open source outfits called Adafruit, America, and they've just announced their Raspberry Pi I/O board. I've seen the pictures of it, which is exactly the same size as a Raspberry Pi.
I wouldn't advise just bending the GPIO pins to fit 9-pin Atari joystick.
Well, it's only $35, right? So, what's the worst? What's the worst that's going to happen? In general, what tends to happen if you mistreat the GPIO is that you blow out the GPIO line drivers on the chip. You tend, unless you really abuse them, I shouldn't say this, but you tend not to actually destroy the chip. You just destroy that pin. Yeah. I'm kind of hopeful you can plug a PS2 keyboard into it, because I have some uses for a separate way into the chip that isn't via the USB.
I wonder if you could comment on the power of the device. Roughly what equivalent speed in PC hardware, say, is the processor, and roughly what equivalent graphics cards like. I know your architecture is very different from PC graphics cards.
Okay. How much performance? At 700 megahertz, not overclocked. Got a lot of overclocking.
What does that mean?
So at the rated speed, we're about twice as, starting with ARM hardware, we're about twice as powerful as the most powerful RISC PC that ever shipped. So the last in the line of Castle machines, we're about twice as powerful as that. In terms of PC hardware, we're like a 300 megahertz Pentium 2, that sort of level of performance. So we're like a respectable machine from the turn of the century. I think it's probably
general CPU.
In terms of general CPU performance. In terms of graphics performance, obviously multimedia, video, very, very high performance. So we can very comfortably do 1080p, H.264, and Epic 4 decode. We can actually do encode as well, but we haven't exposed that functionality yet. In terms of 3D graphics performance, we're a Talmo 3D core developed in Cambridge, so it's a British graphics core. I guess we're about as powerful as the most powerful mobile phone in existence at the moment. So Galaxy S2 type level of performance. Relating it back to consoles, somewhere between, like an Xbox One, or somewhere between a PS2 and a PS3. Better than me. On the all, I can draw faster than that. I guess probably like a GeForce.
How much of that is exposed at the moment?
How much of the multimedia?
Yeah.
So we expose OpenGLES to API to C and also to Python if you wanted. So it's pretty reasonable. I mean, some people may have seen us running Quake 3. We run Quake 3 at 1080p anti-alias very nicely, and that's just a regular GL application. It's got about 20 lines of voodoo stuff at the start to bring up the display compositor and get a composition surface to render to. But that's Broadcom specific proprietary stuff. But Windows systems are always proprietary. So.
If you really want us to hack it, you have to open up. If you really want us to hack it, you have to open up to the register level.
Yes. There's an interesting point about open hardware, which is that it's not generally the case that nobody tells you, apart from I think ATI sometimes, nobody really tells you how their graphics cores work, how to program them at the register level.
It's a bit more than a ULA.
Yeah, a little bit more. But we do provide a data sheet which tells you when the UARTs are and the time zone, which is kind of the level that say OMAP gives you without NDA. So we do provide enough information to let people port a new OS on, and some people have been porting different OSs on. There's been a RISC OS port. I think there are one or two other ones out there as well.
For now, Well done on the Raspberry Pi. I think it's brilliant, and I hope it will change, the way programming is done in schools. What is the thing that you think people use it for that's most shocked you and thought, wow, this is great? That's put a screen back in your stack, so you're doing a lot of the hard work.
Do you want to do this one? You heard? What have you heard?
Well, at the moment, I must admit, I tend to watch the Twitter traffic a lot. So far, I must admit, most people are talking about putting various control applications and things. I haven't heard anything absolutely tremendous yet, because the trouble is most people, of course, haven't got one yet to play with, so it's a bit difficult, but I think that once people get hold of it, so then they'll let their imagination rip on it, because people are limited by something like an Arduino. You think, well, I can do this, and then you realise, well, actually hasn't got the power to do it. Raspberry Pi will have the power to do it, so I think that people will suddenly realise, actually, I've got something that I can really, it's that big, and I can make a portable application, and it'll be right here. So I think there'll be some tremendous new applications coming out, but it's early days. I must admit, at the moment, most of the things I see seem to be people porting Spectrum emulators across and lots of things, and operating systems and all, which is great. I mean, there's no problem, but we really want to see some up-to-date stuff going on. But as I think it's early days at the moment.
I can actually get a couple of these if you like, because I've been. Yeah, I mean, some of I obviously talked to a lot of people on Twitter. It's me who's behind the Twitter account, and some of the most exciting ones I think I've seen so far are looking at using the Raspberry Pi to track meteors, which is super cool. I thought that was brilliant. And then right at the other end of the scale, I've been talking to a guy in Cambridge who has a very severely developmentally disabled kid, and who needs monitoring hardware in his little boy's bedroom. Can't afford it at the moment. It's really very, very expensive, and he's looking at building his own using a Raspberry Pi, which I mean, it's not as glamorous as some of the applications that we've heard, uses sending balloons into space and so on, but I think that's probably my favourite.
My favourite is actually a Sinclair one. But very, very early on, we had an approach from some people from a QL user group who wanted to run a QL, wanted to know if they could have it boot into a QL emulator, the balloon inside a QL box, so they could pretend they were using a QL. Apparently, there is now a lot of old age mortality in the remaining QL hardware stock. People are looking at this as a way of keeping the QL going. So I like that. I thought it was really nice. I have one more. Are we done for questions? I have one more thing I'd like to say. Yeah, games, abandonware in particular. We are very interested. I know, this is supposed to be about the future, but we are very interested in abandonware. We're interested in giving people ways to legally run content on the device, emulated content on the device. If there are people out there who know where copyrighted things resides, or own copyrighted things themselves, please do get in touch with us. It would be lovely to be able to ship the thing with some of the best games from some of the platforms of your. I would love personally to have to have a wife who didn't try and grab the microphone.
There's
Any interest?
it runs on Spectrum. The free version of that game that you can have.
Oh, awesome! Thank you. So we really would like to use that. I mean, there is some amazing content out there, and the sad thing is often the copyright just wanders off to places where people don't even know where it is. So it would be lovely to get some of that content on there. Just thought it was a good community to say that in.
Yeah, and another thing we would really, really love is looking at the listings magazines over here. We've actually had a community magazine just come out in the last week doing listings like we used to have in the 80s and typing away making mistakes. Now, it would be lovely if some of you guys could actually produce some code that we could be farming out to kids, saying, well, type this in and see what happens. We don't have enough bodies at the foundation to be doing as much of this stuff as we'd like to, and we could really, really use your help with that.
Are you guys interested around for
Yeah.
a little while longer?
Yeah, we're going to stick around. We'll be in and out.
Okay. We've run out of time for
I'm
questions.
sorry, I'm hogging.
But yeah, please join us in thanking Liz.
Thank you.